Well, good afternoon, everyone. You're on mute, Frederic.
Good afternoon, Jordi.
Welcome. Welcome.
Nice to meet you.
Same here.
Good afternoon, everyone. Hello, Alan.
Hi, hello.
So I guess what we can do is to start the session for today. Just to remind you that all of these sessions are recorded, and all the sessions are afterwards uploaded on YouTube, so you can review the video once you have a question or you don't feel comfortable with any topic we have discussed during this 1 hour session. Today it's a very special day because we have Carmen from CERN who joined us. She's from Spain, actually, and I guess, if I recall correctly, from Galicia region. She's working on P4 for the CERN, and she's dedicated to a specific P4 project, which is being able to establish a policy-based routing based on setting flow label, IPv6 flow labels. Correct me if I'm wrong, Carmen.
You say it perfectly. So
this is great. She has installed our software yesterday, almost alone. That's a very good sign, and it works well, I see. So this is the first thing, and today we have the chance to have Csaba, who will talk about something very important with FreeRtr, which is related to policy-based routing. So this is a little bit linked to your project, Carmen, and the possibility to, I think it's to use a FreeRtr mechanism, so that you can set some specific packet criteria and then establish and then handle this policy-based routing. So this is for today. So MC36, so Csaba, the floor is yours.
Hi, let me share my screen first. Jordi, can you please enable the screen sharing?
You can already, sorry.
Ah, okay. Thanks. Okay, do you see the screen?
Yes, we can, perfectly.
Fine. So this is the the famous FreeRtr homepage, and they are the test cases. First of all, at the moment you cannot spot exactly what you need, but we talked previously in Frederic, but it will appear soon. So, for example, the classification is in Cisco called QoS and hierarchical QoS and so on. You can find the actions here, the code-based things, the match criteria, the set criteria, and the others are routing. And also the related things are the ACLs, because here is a match action with ACL in QoS. Sorry, and there are the access list test cases that test at the moment for TTL or TOS, but we will add the flow IPv6 flow label as soon as possible. Give me a week or so and it will be here or sometimes we will see. Okay, so taking a closer look on the TOS test case, it's not too much. First of all, here we have R1 with two access lists, one for IPv4, one for IPv6, but basically they are the same. And we have R2. They are connected on Ethernet 1, and here we have access group applied. So the access class is applied, and the access class basically drops the type of service 110 between 120, and then some ping tests. And we can run this test case by hand. Let me show you. Do you still see the screen?
Yes, we can see.
Okay, and the thing we needed is the crypt ACL 11. Okay, so now this command starts to jam processes, to FreeRtr processes, and then executes the pings that are written in the test case. And then tells me that it succeeded and it exits, but we can add the wait command here. We can add the wait command here. And with this wait command, it won't exit immediately, but it will keep the routers running. Okay. So at this point, we can access the routers. It is 20,001 and 20,002 for the two routers. Here you can see the WAR config. At this time, the commands are extracted to the long form, so not the abbreviated commands. And this guy have the access list. I think it was test 4 and test 6. And the thing is that you can see that it hit 10 packets, and it was the deny part, also 10 packets here, and the rest was permitted. I think we can spot now a new terminal to the other router, and let's see what we should ping. It is an Ethernet 1, so it is 1111. Okay. Okay, it works. And I think it is 1111 for the toss. And we got back immediately the denied because the ACL sent us back the deny keyword. Let's confirm this with okay, so we got the 1,000 matches. Now let's give another spin. We have 2,000 matches here, so it really happens and matches here. And now let's do a different toss, for example, 2222. Okay, now it increased by 1,000. Now let's give it a bigger number, and it reached 12,000. So this test case really uses the access list and exercises the match criteria, and seemingly it works. Also, we have when was the access list last matched and so on. If it's a time-based access list, then it can have a timeout, but it is not tested in this specific case yet. So this is one of the part, and you can prepare yourself for the similar with the IPv6 flow label, because I will add it after the meeting. The other part that you could be interested is in policy routing. It is PBR. Not too much test cases here, but I think. Sorry, before continuing with PBR, do you have any questions, Carmen, about the ACL matching? Was it clear? Should I talk a bit slower about it, or should I express myself in different words, or was it clear?
I understand it, but this is the first time I never use it, so everything is new for me.
I see. Anyway, are you familiar with the Cisco configs?
Yes,
because
yes.
because
I
it's
use Genius 3.
I see.
at the university.
That is a good start because the config is much like a Cisco. We can go back. Which was it? It was ACL11. Yeah? ACL11. It is a Cisco-like, we call it. So
Yes,
here
access
we define
list,
we
VRF,
define
yeah.
an access list. We define. Let's skip the physics part now. We define a VRF. It is needed because everything is a VRF, but you can listen Frederick's one explanation about it on the channel, and just an interface. So it's not too much at the moment. So it's really very basic. Okay, so now let's go back to the PBR because it's an interesting ingredient. The PBR part, for example, with NextHop or NextHop and interface or between VRFs, I think we can use the interface on NextHop because it will be needed for us in the future. So here here the test case is a bit trickier, but the thing is that this router don't have any routes defined, so there is no IPv4 route, VRF-v1, and so on. Just the PBR configs. The same goes for the R2 router. This guy also don't have any routes defined, so the routing table should be empty, except the connected routes, of course. And the same goes for R3. That is also just the PBR configs. And then we accept that we can ping between the loopbacks. This is the 222 network here, the loopbacks. And this is what we test for. It is route PBR03. Now I start with the wait immediately. Okay, so now if we examine the routing table first of all on R2 because it has the much routes. Okay, only the connected and the local routes are here. But if we check the PBR tables, then we can also spot the matches happened similarly on the QoS test. We can see that there was received packets about half a minute ago, and also we can do the flooding. Okay, it is R3, I think. This guy's routing table is also empty, but what should be able to ping? It is A2B4. It is 2221. Okay. 2221 per VRF-v1 source loopback 0. Okay. Now let's bump that counter. Okay, so first of all, the access list matched, and then the PBR matched on both directions. It is because both R1 and R3 have an empty routing table. So basically, we checked it now here. If I put a bit more packets, then we can see that the counters are increasing here. It is the same show command, but if you issue it with delay or watch, like in Linux, then it displays continuously the show command. And if I stop the ping, then the counter stops. So that's it. Basically, the policy-based routing also works. But we will compile you a bit trickier test a bit later. The last missing part, I think, is, for example, SR, how I call it? SRage. Shit, I had to find this test case. It must be somewhere in MPLS, I think. MPLS, not BR, not MVC, not LDP, NSH, no, not NSH, PVG. SR. Okay, I think it is. Explicit pass. Okay, traffic engineering with explicit pass. It is a bit longer config now, but hopefully we can quickly dig through it. Okay, so we have two routing protocols. They are my favorite home-brown routing protocols just to have some connectivity. Oh, sorry. And then we have a loopback one with RSVP enabled. It is needed for MPLS-based traffic engineering. The Ethernet 1 and Ethernet 2 defined with some addresses, RSVP enabled, MPLS enabled, and the routing protocol is enabled on it. The same goes for R2. And then we define a tunnel. It is the same as in Cisco, except this domain name thing. It is an overloaded command. It is the explicit pass that you compile to the tunnel. And then the tunnel mode is point-to-point traffic engineering and some address on it. And the same tested for IPv6. And then we have R2, where we have the routing between Ethernet 1 and Ethernet 2, and the RSVP enabled and MPLS enabled, but not too much about tunnels. And then we have R3, where we have the tunnels and the corresponding addressing on the tunnel. I think it is. And then we have R4, where we also have a connectivity, but no tunnels at all. And then finally, we ping the loopback ranges, and finally we ping through the tunnels to check that they came up and the traffic passes through. It is MPLS-T 19. MPLS-T 19. I forgot the weight. Yes. Okay, while it tests, I think we can already open the routers. I think I can terminal monitor. Let's see if we got something. Okay, the neighbors came up finally, and the ping and the test finished. If we check the tunnel 1, we can see that it sent 10 packets. And show IP for S3PV1 summary, then we can see that there are two tunnels. The description is R3's tunnel 1 and R1's. So this is the incoming tunnel, and this is the outgoing tunnel. Sorry, the second is the outgoing tunnel. And we can check the the details of the tunnels, and then you can see the ingressing interface, the egressing interface, the labels associated, and when was it created, when was it updated, and so on. Okay, so if we display interface summary, and now the tunnel 1 and tunnel 3 are both quiet, but what if we open a new terminal window and okay, so I think it is 3C3 to the remote end, but in VRF-V1, and let's give it a size, and let's repeat a lot. Okay, and now you can see that the traffic on the interface started increasing. Obviously, it is an unidirectional tunnel because MPLS traffic engineering tunnel is in one direction, and it does not put the traffic back to the tunneling interface because it's just a label that gets popped by the previous router. So this is why we already see that RX and TX on Ethernet 1 and only TX on tunnel 1. So this is the tunneling part. And the only thing needed for it is the destination, the mode of the tunnel, and domain, which is the explicit pass. It is a shortcut here. Okay, and now let's cook something that is a bit more interesting. If I start a local router here, and if we wait a bit, then we can compile all this together, I think. Okay, the neighborship is up, so it is a good news. First of all, I removed my favorite redistribute connected and redistribute static commands. Now I define a tunnel. Tunnel source loopback 0, tunnel VRF1. Okay, tunnel destination and tunnel mode. If you can spot, I precompiled a very long tunnel for you. it goes through my home network, which all the nodes uses FreeRtr. Let's see what we got. Okay, we got the tunnel domain, tunnel destination, and tunnel mode. Tunnel mode. We have a lot of tunnel modes here. The more interesting is SR-MPLS or SRX. It is the external. I will show you in a packet capture, but this guy is the source routing header for IPv6. So if you plan to run a pure IPv6 network without MPLS, then SRX is your best friend. We will test both. But first of all, tunnel MPLS. Okay, we have the tunnel mode. I think this tunnel is up. Okay, it is up. So let's assign it to a VRF. Not too much at the moment. Shit, I forgot to remove from the BGP. Okay, now I remove from the BGP. So the thing is that if we ping 1111, it is somehow got to the internet. If we trace route with a lookup keyword, then we got only one hop. Yes, because tunnel, I need to map out the TTL. Okay, now you can see the internals of my home network. It goes to the save, then to the NAS, then to the working, then to the player, then to the message home, then to the player, then player again, Debian, P4Deb, VVV, and VPN, and finally my parents, and it exits here to 1111. If I shut down this tunnel and I trace route again, then it goes directly from save to message home. Beforehand, there was 2 other hops, and finally it arrives at hop 10 to 1111. Now let's capture a bit. I think we got enough. And let's see what's in the capture. It is Ethernet 1, I think. Ah, yes, here are the pings. Okay, so here the packet went out with only one label. I think I did a mistake because it was a tunnel shutdown command. Yes, this tunnel is shut down. So let's no shutdown it. Now let's ping again, but first let's restore the capture. And hopefully it's enough. Okay, let's find the ping. Ah, it is here. And as you can see, when this guy sends to the 1111, then we have a lot of labels. This is the segment routing path included. This is the segment routing path included. It is a lot of labels, then finally a ping. And obviously the backward direction arrives with one label only. Okay, now let's use a different tunnel mode. We can use point-to-point traffic engineering, but it is the past. Hopefully the REST-VP-based traffic engineering is the past. Tunnel mode SRX, I think it is a bit interesting part. Okay, the ping still works. Then we can trace route. At this point, it seems that my parents are connected to the Telecom Hungary, and they reroute the traffic to Deutschland. Interestingly, if I shut down this guy, then it directly exits from MC Home to the internet. My local internet provider does not do any, so they don't support trace route, unfortunately. Okay, so no shutdown, and let's do the ping. Yes, it works. And packet capture Ethernet 1. And let's see what goes on the wire. Okay, so it is the request. And you can see the routing header here. And you can see the pushed addresses. So this is the path in backward order, how the packet will traverse my home network and finally will reach 1111. On the last pass, it will go without this segment routing header because internet routers don't support, obviously, the segment routing header. Okay, so this was the IPv6 segment routing, and now let's see some trick, and let's mix and match things together. Let's define an access list. Let's call it ASDF. Let's do permit every protocol from any source, from all ports to every target to all ports. And now let's do the TOS matching, and let's do only TOS matching for 1, 2, 3, 4. And hopefully it accepted everything. Yes. Okay, so we have the access list and IPv4 policy-based routing in VRF v1. It is the first rule. Access list name is ASDF. Target VRF is v1. And the next hop is 1111 because it's the corresponding, and this is how we route the traffic to channel 1. And the interface, let's do for sure. Let's see what we did. Okay, so we have the access list, we have the policy routing, and we have the tunnel. Very good. Then the moment of truth, let's trace route 1111 with lookup and with TOS 1111. We matched 1, 2, 3, 4, so the accepted behavior, sorry, it went by the direct routing, my bad. Let's trace route 8888. Okay, so 8888 with TOS 11 went directly to my internet provider. So safe and MC home. But if we trace route with 1, 2, 3, 4, then it went to my parents. So it crossed the tunnel. And this is the difference. If I trace routed with TOS 11, then MC home and the 8th hop is a public IP. Here, the 8th hop is still in my private IP, and it still crosses the tunnel. So I think this is what you needed, except that here we will have soon the flow keyword, and all the commands will have the flow keyword to match and set and so on the flow. And at that point, you will be able to do the same as I did here, that is policy-based routing based on TOS. And you can define more tunnels and you can match more TOS parameters. I mean DHCP, sorry, this is the new name. And then you can policy route the packets to different tunnels to take different passes in your core. So I think it is. And back to FreeRtr side. Sorry, my bad. Back to FreeRtr side, the test cases. The thing is that fortunately these things are very well covered in P4 also. So we have the ACL matching things, and we are testing here the different kind of ACL matching. Here the interesting part, if the egress and egress interfaces work fine, we don't test explicitly for the ACL parameters. And on the routing part, somewhere I think we have the policy routing Where is it? Okay, we test for the SRT, which is very good. And where is the policy routing? It must be somewhere here. Okay, let's grab it. Ah, here we test with the interface and next stop. Exactly, this is what I did in my test here. Okay, so was this small example is what you meant to have? I mean, except that I tested with TOS, but it will work soon with the IPv6 flow labels.
So Carmen, if you have a quick look at what he explained, these are all the building blocks that would be used in order to achieve your goal at CERN. So one of the
I
first
think I will
thing,
copy paste the configs to the chat for an easier for the future.
Yes. So basically, what the key things you have to remember is that in order to achieve your goal, which is being available to steer and influence the traffic based on IPv6 flow label, the first things to do is to identify the flow, being able to identify the flow label. And this is done using the access list example he showed you using the TOS. If you remember correctly, the type of service is the 7-bit header. So yeah, it's the 7-bit header that would qualify the type of service. I'm not sure if you remember your networking course. Your networking course, you have this 7 bits that will identify the traffic type, and this is done using the access list. In your case, soon you will have the another keyword which won't be TOS. It will be flow or flow label or something like that, where and this access list will be able to identify flow label among the traffic received at the data plane level, at the interface level. The second thing he showed you is the possibility to create different tunnels, the flavor using SRX and SRM. I think it's SRMPLS. The
yes,
past.
it is.
What you are calling the past, which is the RSVP stuff.
This is RSVP is the third one. I haven't shown it because RSVP is a 20-year-old technology.
Well, yeah. So, and so you have this PBR possibility, and then the possibility, and when you combine everything, you achieve your goal. But then you will achieve your goal. But then here it will be, of course, it won't be the TOS. Is you can gather the configuration from your and take some traces, and then you will be able to reproduce this once the flow label tag identification will be available. We'll give you a notification. We'll send an email to the RAR user mailing list.
Okay, so should I develop this or wait for RARE-freeRtr? Right?
Yes, they are already there. You just have to put the things together, and this is already tested well because I and Frederick we both run a P4 core at home. So all the routers here, if I'm still sharing my screen, IPv4 SRP1 database. So all these routers, they are. This is my IGP, and my IGP nodes here, and all are routing P4. To have some throughput. And interestingly, they are encrypting the link and doing a lot of fancy things too. So yes, everything is here except the flow label, but it will arrive soon. It's not a big deal. I have checked the code, and it's only my laziness that it was not here already.
Okay.
So Carmen, basically you won't have, in order to precisely answer your question, you won't have to develop something. However, you will have to reuse
But you
it.
can if you wish. So feel
Yes.
free to grab the sources. It is on the GitHub, or I'm much.
Yes, I'm going to check it, and I need to study this and understand it, of course.
You can on FreeRtr there is a link, browse sources, and here is some instructions on how to start, and then you can browse it online. It's the same as on the GitHub, so it's not a big deal. But basically, if you are interested on FreeRtr, it is here, and for example, for IPv4 and IPv6. For IPv6, here is where I parse an IPv6 packet and put it to the packet store. It's a Java structure. Or if you are interested in P4, then they are in the miscellaneous folder. And I think I start with the big guide. It is the P4 BF. BF stands for barefoot. And for example, the same happens here, the header IPv6, and this is how we handle IPv6. And yeah, so basically you can find every resources here.
So essentially, of course, you can develop everything, but if you just want to wait a little bit, maybe for the next LHC1 meeting, it will be ready. The flow level.
I think yes, it will.
When is your next meeting, Carmen?
I don't know. I mean, now on Monday and Tuesday there is a meeting, but it's just like a colleagues. No? I need to explain how is the project, but it's not nothing very. It doesn't need to be done. Yeah.
Okay.
I have time, no problem.
So don't worry, it will be normally done at some point. I'm not sure when. If
it will be quick. It will be quick because everything is already here. Again, it's just my laziness that there is no CLI globe to match and send them.
So we will keep you posted on the flow level availability, identification availability. And the only thing you will have to do is to replay this video in order to match not the TOS this time, but the flow level. And then you will be able to steer the traffic as per your requirement.
I think I can further shape it a bit, because if I do a clear counters and show interface tunnel 1, then we can see that we don't have any packets here. If I ping with size a bit bigger and a lot of packets, and those, I think 1111 is the directing. Okay, it's enough. So we can see that there was no transmitted packet on tunnel 1, but if I do with the right toss, that is 1, 2, 3, then it does not work. Shit. Something happened. Maybe not SRX. Mode SRMPS. Or maybe this tunnel is not working. Or maybe it's not nothing interesting. Okay, the packets are sent to this. SRX. What the hell? Okay, but it worked before. Something changed. The demo effect. Let's see where it goes.
That's a great moment.
But it reached the destination, then why ping does not work?
Not worry, Csaba, you have
Okay,
60
okay, I think
minutes.
we have got it. Okay, we have got it. So this is repeat route and size route. Okay, there was no packets at all. Pertos 1, 2, 3, 4. Okay, we can see that it's a bit slower. I don't know what happened that why stopped in the middle. Maybe I had some connectivity issues somewhere. Okay, now we can see that it's really steered the traffic here. And if I ping with a different host, then it is much faster and it's the same 209 packets here. So basically it's there.
Silly question for the audience, Csaba. The TOS is a decimal value from 0 to 127.
No, it's an 8-bit value, so it's 255.
It's an 8-bit. Okay.
Yes, you can overwrite everything.
I thought it was 7.
But I think I also handle DHCP at least on the match. Yes, for the ping command you cannot put the DHCP, but I think for the ACR matching you can specify the DHCP. Yes, and there will be the flow. Here is the DHCP matching.
So Carmen, if you want, you can already steer traffic from different criteria other than flow label, but soon there will be this infamous flow label available keyword and we'll have a next session with you demonstrating how you can steer the traffic with it, maybe. I'm kidding. I don't want to put some pressure on you, but it would be fun to have it actually.
Okay, if you want, no problem.
Of course, we will help you to replay everything before having some bad demo effect. Any question from the audience? Alan, do you have any question?
Not for the moment. I just want to thank you, Frederick and Jordi, for the opportunity. And Csaba, thank you too. I'm starting the studies on the before and the FreeRtr now. I'm a student, a PhD student at Unicamp. So thank you all for the moment.
Okay, so welcome to this project, I would say. This is a great opportunity for us to have these new data plane available, simply because now with this new technologies, we have the opportunity to write programs and that are able to switch traffic, a high amount of traffic rates. So this is a great moment for us, and we are planning to handle this 1 hour session normally every week. All sessions are recorded and will end up in our YouTube channel. So if for any reason you want to replay something, please feel free to look at these videos, and it is also possible for you to access the older videos where we are talking about I would say how to tackle FreeRtr from a beginner's point of view. So today was a special day for Carmen, actually, directly related to her project, and I hope to have some news from you.
Thank you for everything.
No problem. apart from that, from the news, I'm not sure if you have had a look at if you're following the GitHub repository. One thing that is quite fairly new at FreeRtr level is, and also at the data plane level. So if you are running FreeRtr with DPDK or and soon P4 switch, you will be able to also implement automatic multicast tunneling relay function. So this is great because this is I would say from the commercial point of view, I think it's still in test phase. And the basic idea of IMT relay function is to give access to a user acting as a receiver in a non-multicast network to access resources from the service provider point of view. So essentially, I am a receiver. I want to access a specific multicast feed. I would establish, of course, without any knowledge of IMT relay function, but I will establish a tunnel to the IMT relay, and then I will be able to join a multicast enable network and then the source. So that's something that appeared beginning of the on Monday, I think, in one of the commits. So this will be available at least for those who are running a DPDK version. It's already there, so you can act as an IMT relay.
Yes, so if you take a look on the GitHub repository, it's a fast-paced development. So I basically quickly put things when I have an idea or or so. Yes.
So any more question, Carmen?
I don't know, a lot. I need
A
to
lot.
to start and to see everything. It's the first time.
Of course, you have 9 minutes if you want to ask even silly question. We are here to help and make you try to kickstart your work and understand. If don't feel, you know that.
So basically, this back to this tunnel thing and the config. So basically, if you take a look on the Cisco's MPLS traffic engine config guide, and they also do the same. That is a tunnel interface and some loose or strict paths, and this is exactly the same. They also do the Cisco does the policy-based routing on the interface level with route map. It is done here with access list. It's much like an iOS 9K because they also do the policy routing with ACL there. So basically, it's not too much to have. The only missing part is the flow match here.
What is maybe what is quite similar to Juno's world is the tunnel domain name keyword, where you put your list of hops from both tunnel endpoint. I think it's explicit. The keyword in Junos is explicit path.
Yes, but I was too lazy to introduce a new tunnel and the parameter.
Yeah.
So I overloaded tunnel domain.
So here it's just called tunnel domain, but basically it is the same. And then you put here some hops that are strict if you want to enforce some specific physical path, or can be loose hop like a loopback that is advertised into the IGP. And then the routing will try to do its best to actually follow the path you have, the explicit path you have specified, composed by strict and loose hop. So any more final words, Csaba?
Not too much.
Not too much. That's great. Carmen, Any final words?
Oh,
You
sorry,
seem a little bit overwhelmed. I mean, you were well. At least you have did a lot of progress since yesterday.
Yes.
So I would like to thank you all for attending this session. We will pursue with another session next week with another topic. We'll see how it goes. Maybe it will be your turn to present your traffic tunneling via flow labels, just in case Csaba managed to make it available soon. Anyway, no, I'm teasing you. So talk to you next week, and meanwhile, have a good end of the week.
Bye-bye.
Or maybe
You
see
too.
you tomorrow.
Bye.
Bye-bye.
Yeah,
Ciao, ciao.
bye.
Bye.
So how can we stop this recording?